This year we're lucky enough to be joined by Philip Hoare, who's Senior Lecturer here in this department. And he'll be talking a little bit later, I think, just saying a few words about the process of collaborating and experience he's had of collaborating, some of the challenges, etc. And there'll also be a couple more staff you may recognise if you're someone who's done creative writing before. So Rebecca Smith will be joining us, very pleased to say. And even I'll be attempting one this year, quite terrifyingly. So we'll see how that goes. We've also been lucky enough to have each year someone to think about science and poetry in a more general way at the beginning, to kind of set up the stall. What kind of relationships are there between science and poetry? So we're very lucky to be joined by Dan Brown, Professor Dan Brown today, on my right, who's in the English department, who joined us this September. Has done extensive research into science and poetry, from the 19th century. So I'd like to invite him just to say a few words about science and poetry and different starting points, what the relationships might be between the two. Thanks
Okay, thanks,
Will. I'm going to eat my lunch as well.
And thanks, Francis and Will, for inviting me to the Litmus lunch and launch. One letter missing between those two words, lunch and launch. Almost a pun. So as we were saying, I'm a newcomer to Southampton, so I was particularly interested to, and happy and excited indeed, to hear about the Litmus project, which sounds a wonderful innovation, and very happy to be involved modestly with it here at the start. So while I practice neither science or poetry, I have an abiding interest in the relations between the two, especially relations between poetry, physics and mathematics in 19th century Britain. In recent years I've been exploring the uses that Victorian scientists make of poetry in their scientific research, and accordingly thought that I could talk briefly about this confluence today, which, like the Litmus project, cuts across sort of disciplinary separatism of the modern university, the university that gets going in the late 19th century and is still going reasonably strong. The sort of departmentalisation of knowledge we're all familiar with. So let's see, if we go right back to the beginnings of recorded Western thought with the pre-Socratic philosophers in the 5th, 6th, 7th century BC. This is a time when philosophy and science are not yet distinguished, and we get such thinkers as Empedocles and Parmenides talking about the basic nature of being and of the universe as a scientific and philosophical question, and many of them, principally Empedocles and Parmenides, wrote their science, early science, in the form of poetry. In the 1st century AD, the Latin poet Lucretius writes on the nature of things, his great poem on atomism, which then becomes a model for Latin didactic poetry during the Renaissance, which similarly cast a whole lot of new scientific ideas, usually in rather indifferent verse. It was just the mode of expression, poetry. It was a bit dum-de-dum, but it's there, and it's technically poetry. So they cast their scientific ideas in rather indifferent verse, while conversely, such poets as John Donne borrowed imagery and ideas from contemporary science in rather arresting tropes, arresting metaphors, analogies for quite discordant, quite unrelated subject matter to do with human relationships and love and so on. Then throughout history, many canonical poets, well-known poets that are sort of studied and reread over the years, like Alexander Pope, William Wordsworth, Jerry Manley Hopkins, Alfred Tennyson, Wallace Stevens, have turned to science for imagery and inspiration, and also for fight too. There's lots of fights with science. Less widely acknowledged and considered are the uses that poetry has for science, especially the hard sciences of maths and physics that I'm interested in, that I can't claim to know too much about. So many of you know when Newton's Principia was first published, it was prefaced with a Latin ode by Edmund Halley. Most of the scientists in the next great age of British science, to zoom ahead, which is focused in about the middle third of the 19th century, when British science really gets going, gets professionalised, and you do have something of a renaissance in the life sciences, obviously with Darwin and so on, but also in physics with people like James Clerk Maxwell, who I'll talk about in a minute. So many of these scientists, they didn't have a scientific education particularly. They all had a classical education, so they'd study a few books of Euclid, that's it, and the rest would be full-on classical authors, literary authors. And part of that education, they'd have to write poetry in Latin. So many of them came to science as a hobby. They'd have scientific toys and games, but they didn't study it at school. Later on, some of them could study it in the mathematical tripos in Cambridge, and that's about the only course that gets going and gets professionalised in the 1830s, 40s, 50s. And if you were lucky enough to be in the Scottish system, you could have quite good experimental courses. But in Britain, experimental courses are seen as very working class. You don't touch things, you don't make things, you don't work in a laboratory. It has to be theoretical, and that's why the mathematical tripos was all about. Fitted in with the aristocratic ethos of the Oxbridge universities. So anyway, so they had classical backgrounds. They were used to writing poetry. Some of these figures include, and later on they would write poetry in English too, about their science and a range of them which I'll talk about. So these figures who both practice science and wrote poetry include the mathematician and astronomer William Rowan Hamilton, Irish scientist who invented quaternions, the astronomer John Herschel, the polymath William Whewell, who first coined the word scientist in 1833, the geologist Edward Forbes, biologist T.H. Huxley, also known as Darwin's bulldog, and the physicists John Tyndall and James Clerk Maxwell. And during this time, we get Lucretius's big poem I mentioned earlier on the nature of things sort of comes into its own. It had been taught in classical courses for centuries as literature, as an elegant Latin poem with rather fanciful, slightly crazed subject matter. All of a sudden, in the 1860s and 1870s, it starts being regarded as a prescient work of science, as people become very interested in atoms again. And there's a big gold rush around atoms in the mid-19th century as the building blocks for everything and what this meant and how they were working. Very interesting for us, perhaps, because at the time atoms couldn't be seen. No one had seen an atom, so they're completely hypothetical, speculative critters. So they're purely a work of the imagination. And so they were up for grabs. And you had John Tyndall with his friend T.H. Huxley and so on, absolute materialists, agnostic. T.H. Huxley comes up with the term agnostic. And then the other Scots physicists, James Clerk Maxwell and his friends, who tended to be Presbyterian, quite religious. They both headed up factions that were battling with each other for the sort of rights to sort of describe the atom, and with that, the rights to sort of claim Lucretius as their grounding text. So this sort of poetry becomes very important to them. And from a safe distance, quite a sort of funny conflict. Anyway, so they're both trying to claim Lucretius as sort of venerable beginnings to their competing theories of atoms. Tyndall, as a materialist, notoriously traces everything to these atoms and the way they behave with each other and the way they bond with each other to form molecules and then other bodies, including living things, and right up to determining the way we think and the way scientists come up with theories and artists come up with their works too. So it's completely mechanical. Atoms get together, bond, and it goes on from there. So this is something that Maxwell wasn't keen on. There's no free will here. And he mocks it in his 1871 poem to the chief musician upon Nabla, a Tyndalic ode addressed to Tyndall. It's a lecture given by Tyndall, a mock lecture, which was Maxwell delivered at the Red Lions dinner, which is the sort of carnivalesque sort of dinners that they had at the British Association for the Advancement of Science, where you turn everything on its head and get as drunk and as naughty as possible. And they'd write songs and poems in these groups that started in 1839. So Maxwell's quite good and quite vicious and quite funny, I think. So a Tyndalic ode, and it begins, I come from Imperium, this is the Tyndalic lecturer speaking, I come from Imperium fires, the sort of transcendental fires. I come from Imperium fires, from microscopic spaces, where molecules with fierce desires shiver in hot embraces. So where molecules with fierce desires shiver in hot embraces. So the molecules are seen, the bonding that creates everything is just seen as pure lust. They get together, it's all the sort of sexual embraces, and this is shivering in hot embraces. So these lascivious molecules are sort of casually characterised Tyndall's entire cosmology, sort of identifying his metaphysical materialism summarily with licentious hedonism, with lust. And this is also a rather cheeky and below-the-belt reference to Tyndall's reputation at the time. He was a notorious bachelor, a fashionable professor of the Royal Institution. He was always getting the attention of the ladies and society ladies, and there was a lot of gossip about him, and he was seen as sexually sort of immoral and casual. So there's a reference to that there too. That was topical. Anyway, moving right along. As well as being used publicly and politically to mock and satirise scientific opponents, poetry was also used privately by Maxwell and many of his peers as an adjunct to scientific discovery. And this is interesting, I think. So Maxwell, studying the mathematical tripos, very frustrated with it. It was so dry. He loved his experiments and everything, which he'd do in his room for recreation, but he wasn't allowed to do them as part of the course. And he was also interested in philosophy, and there was no philosophical groundings to his science there, as there was in Edinburgh, where he comes from. So he was trying to find a basis for scientific discovery, and this is the big breakthrough, I guess, in the 19th century. Everyone, for a few centuries, everyone was just looking at nature and thinking, God created it, so it's all there, we can just describe how it is and get to know how God is. There's no surprises. It's a sort of tautologist thing. You only find what you first put there, and you see God in it. To come up with, the big question becomes, well, how can you actually discover new things? And so imagination becomes very important, and ways of actually grasping and describing the outside world become very important. New ways that don't just say, oh, it's a book of nature that God wrote. We're just reading it as humble servants. So poetry becomes very important to Maxwell, and and arguing by analogy. How can we sort of hypothesize things by analogy and describe them, and actually see whether we can find something new, a new model for the way things work, especially at the sort of physical level, the most radical levels of physics. And so he looked at, in exploring the potency, scientific potency of analogy and model making in science, he looked to poetry, because lyric poetry is all about compressing, it's all about focusing on analogy, on metaphors, similes, and other arresting models, saying one thing is like something, or is like something that is, we used to think of completely different. My love is red, red rose, I don't know what, I'm sure you can think of better examples than that, but yeah, so that interested in him. So he did a lot of work with poetry, and writing his own poetry and compressing and exploring analogies. Also puns, which he sees as the reciprocal form of analogies, rather cheekily. I won't go into that now, but you can sort of think about it. You've got two terms compressed in a pun, and turn it over, and you've got two terms being unpacked in an analogy. But needn't worry about the mathematics of analogy and puns here, but he does that. He's quite witty and very subtle, creative thinker. Anyway, he goes on. He writes poems about epistemology, of how we know things, in the 1850s while he's studying at Cambridge, and then he graduates in 1854. And at this time he writes his first big scientific paper on Faraday's lines of force, and then a few years later, most momentously, he writes a series of papers on physical lines of force, 1861 to 62, in which he discovers and establishes the electromagnetic theory of light. And he comes up with that theory through his mechanical model, which is a funny sort of mechanism for the ether, the medium through which electricity, magnetism, and light is propelled. A hypothesis that worked back then, and still works to some degree now, I believe. He had this very elaborate mechanical model for this, and when he did the maths for the way these mechanical models work with electromagnetism and with light, they coincided, and he came up through this model. He came up very famously with his electromagnetic theory of light, which becomes so important later on for Einstein and other people. So modelling becomes very important. That comes through his experiments with analogy in poetry. Should I stop there, or should I burble on? That's probably enough of it. But I was going to talk a bit about. Well, just one paragraph, just to alert you to Mac, or it's okay, Sylvester. Sorry, I want to drone on. But lyric, so lyric, as I say, lyric poetry foregrounds and distills the sort of purely formal nature of analogy. So it's formalist, like mathematics. You know, you can think of mathematics as a huge pun. When you get algebraic notation, it can stand in for all sorts of things. So it's an amazingly proliferant puns that the English language can't do as efficiently. So that's obviously, it becomes a place for huge creativity. And Maxwell's contemporary, the English-Jewish mathematician James Joseph Sylvester, who worked with Arthur Cayley, more famous peer, with him poetry and mathematics become almost interchangeable forms. So his inaugural lecture as the civilian professor of mathematics at Oxford in 1885, when he was about 69, he wasn't allowed jobs or even to graduate because he was Jewish until this time. His inaugural as a civilian at Oxford includes a poem he wrote to a missing member of a family group of terms in an algebraical formula, in which he personifies this missing term that's got lost in the heavens as a star, and we track it down and so on. It's quite a nutty poem. I don't know what his audience thought, but it's fine. And he habitually uses quotations from Shakespeare and other poets in his mathematical papers to illustrate them. And he also, he was probably the person that coined more words, new terms for mathematics than any other figure. And he tended to get them from prosody, from the sort of theory of sound in poetry and rhythm in poetry and so on. And he wrote on prosody. He wrote a new book on prosody, which theorises poetry through calculus, whereas we theorise poetry, the rhythms of it, as really simple arithmetic, got stressed syllable, unstressed, it's very crude, whereas he looked at calculus, which allowed a lot of subtleties of the word sounds to be recorded. So it's quite a serious critique of people like me and my peers who are trying to theorise poetry prosody over the last few centuries. And he comes up with a lot of terms in prosody that he brings from his new avant-garde mathematical practice, and vice versa. He wrote a book called, a treatise called The Laws of Verse in 1870. Anyway, I'll leave it at that. I mean, I think there's a huge amount of imagination needed at this time, as I prefigured with the idea of the atom, a speculative entity. No one had seen it yet. You've got the ether I alluded to, which is also a hypothetical, imaginary thing. The energy principle comes about at this time, electromagnetic field theories, and so on, not to mention non-Euclidean space. So it's a time when great imagination was required and very productive, and obviously that becomes a common point between poetry and science, and was recognised as such. Tyndall wrote a very famous essay, a lecture on the scientific use of the imagination, and it's a preoccupation for many of them. As I was alluding to earlier, that see poetry and science very much as play, and the same sort of thing. And growing up, they had no scientific education. They would have scientific toys, and they'd have books of scientific play, which they would read in their spare time, do experiments in their spare time as play, feel very guilty about it because they should be studying classics, but then later on luckily had the opportunity to become scientists. So poetry and science work very much with them as forms of play, and they'd mess around with it and carry on. I'll leave it at that, I think. Oh, slightly nutty effort to try and gesture to all these different things. Yeah.
Thank you.
Thank you.
That's a really kind of useful intellectual history, but also giving us some kind of concepts that actually really bind together different notions of science and literature together. Kind of puns or algebra. I'm sure lots of people might make puns without realising it. They might be engaging in algebra, and vice versa. I'm sure lots of people might be doing algebra and not know they're making puns. So that's really, really wonderful. So I think at this point, perhaps I might read out the pairings to give you a chance to pair up with the person, have a chat to them, find out the research they're doing, have a sort of conversation. And then when you started the conversation, I think Philip might say a few words about collaborating and about how to make a conversation work and how to lead on to the process of
so you haven't measured it. You measure its position here as if it's not
not really that well, but we kind of started our PhD. I write my landers the wrong way around, so normally it would look like that, I think. Last time I did physics was GCSEs.
On the 10th of December 2009, 7 sperm whales, which are the largest predator in the world, they're also the largest animal in the world, and they possess the largest brain in the world, stranded on the coast of the Adriatic Sea in Italy. They've been shocked into going to shallow waters by military sonar exercises at one end of the Mediterranean. One of the whales had travelled 630 kilometres, and together with its 6 male companions, it stranded on the shores of the Adriatic. The route by which the animals came to that point was worthy of Greek drama. Because they'd been scared into shallow water, they were not able to feed. Sperm whales are the deepest diving of any marine mammal. They dive for a mile in depth for up to 2 hours at a time. And they feed 90% of their food is squid. And so they were driven into shallow waters in the Adriatic, far too shallow in which to feed on their normal food. And as they began to starve, actually more pressingly, they began to dehydrate because a whale doesn't drink, it takes its water from what it eats. So as they began to starve, the adipose tissue in their bodies began to break down. And because of where a sperm whale sits in the food chain, at the very top, every item or particle of pollution that was pumped into the ocean, PCBs, heavy metals, organic chlorines, ends up in sperm whales. And as the tissue in these animals began to break down, they began to poison themselves. The release of these chemicals affected their immune system. And the final act in this tragedy was a storm which drove them onto the beach, where they expired generally a whale on the beach dies under its own weight. It's too heavy. The reason why an animal that big can be that big is because it's suspended in the water in another medium on the shore. They basically suffocated. And I read about this in a scientific paper authored by 21 different authors, scientists, published in 2001 in PLOS One in the journal. And this paper ended with a remarkable phrase which seemed to me to be utterly unscientific. It said, "The whales were found agonising on the shore." I started writing about whales in the year 2000 when I became very interested in them. I started whale watching off Cape Cod. And as a writer, I'd never been faced with the physical presence of something so big. Seeing a humpback whale breach out of the water, 50-ton, 50-foot animal leaving its environment into ours, this animal with which we share a mammalian kinship, confronting us with its physicality, to me was, as a writer, was something I didn't know how to encompass. I didn't know how to express it. And the first time I saw a whale do that, rising there, it was held there as though someone had put the pause button on reality, surrounded by this halo of shining dots of diamond seawater. It was an intensely poetic moment. And I responded in an intensely poetic way. I said, "Fuck." And that reminded me that as a writer, I had no way of writing about these things. I had no scientific background whatsoever. And yet I launched myself on a kind of new adventure, which I've been on now for 12 years, working with scientists, specifically on whales, but on other aspects of the sea and marine life. And it's been an amazing journey, and it's very interesting for someone like a writer to try and have to express things about the natural world in many ways, shapes and forms in words. You very quickly, what you find, especially when you're writing about whales, you very quickly run out of words. You run out of superlatives on the first page. I ran out of superlatives in the first paragraph I talked to you about just now. And as I worked, the only sort of reference point I had to write about science and whales was Moby Dick, a book written 150 years ago, amazingly. But a book written by Herman Melville in 1851, very much drawing on the science of his day. He was writing at a time when Darwin was active, later Huxley. He stole from scientific books. He, in fact, nowadays he'd be accused of plagiarism. He was copying things almost verbatim from his book, for his book. But what Melville seemed to me to be able to do, and he did it in a book which is actually an extended act of poetry as much as it is a narrative of a captain going in search of a whale which is bitten off his leg. Although the subtext of Moby Dick is that that's not all that Ahab has bitten off by the whale. That's why a friend of mine called it should be called Moby No Dick. But the whole sort of aspect of that approach of literature, generally literature, to science, came at a point which was a crux point, which is moving, as Dan very much illustrated, and moving from this point where the scientist was an amateur, was a kind of polymath, to the dividing of the ways, this really actually rather disastrous dividing of the ways, in that it's created many sort of disjunctures which we live with now, and the problems of the division of art and science are actually quite integral to some of the greater problems of the world. And it's very interesting that now in art and literature there's a renewed interest in science. I mean, I'm very interested in whale science because it's only 30 years old. You know, we know hardly anything about sperm whales. We don't know why they've got such a big brain. You know, what does a whale need to do with its brain? It needs to move, eat, have sex. That's it. What else would it do? Why would it need such a big brain? Some of these questions, which are metaphysical as much as they are scientific. For instance, Hal Whitehead, who's written the preeminent text on sperm whales' social evolution in the ocean, talks about sperm whales as having a sense of their existential selves, to the extent that he actually posits that sperm whales might have developed their own theories of religion. I had lunch with Richard Dawkins once, I didn't tell him about that. But that whole notion also, as I speak, it's very much in the ether now. I was in Madrid last week at the Prado. There was an amazing exhibition by a contemporary Spanish artist called Miguel Angel Blanco, who has installed items from Madrid's Natural History Museum next to old masters, paintings by Velázquez, by Greco, by Goya, by Rubens. So, for instance, there's a painting of Rubens painting of a young man, it's Orpheus, addressing the animals of the forest. And among the animals of the forest is a unicorn, which is a mythical beast. Right. Actually, a friend of mine who was in a hippie shop the other day saw on the natural history book section books on dolphins next to books on unicorns, which is something you possibly should avoid. But next to this painting, the artist has placed a narwhal tusk. Of course, a narwhal tusk is what was being sold around Europe during the medieval times as a unicorn. It was worth 20 times its weight in gold. Queen Elizabeth was given a narwhal tusk by Sir Martin Frobisher, the Arctic explorer, which was worth the price of a castle. So Blanco has made these correspondences between items of natural history, between geological specimens, between natural historical specimens, and art, making these very extraordinary, merely by placing a scientific specimen next to a work of art, you set up a whole new series of correspondences. You start to bridge that gap, you fill that vacuum in the most extraordinary, exciting way, and I think that's why this project can be really exciting. I'm going to stop talking now.
Thank you for that. That's fantastic. So I suppose, Francis, was there something you wanted to
It was just one
say?
quick thing. I did lead everybody to believe, and I thought I had got it under control, that we would be having a third member of the groups, so that each pair would have a third person with them, who would be a designer or artist from Winchester School of Art, who would be involved with the visual representation of the finished artefact, which last year we did without anybody like that, and it was perfectly fine, and you all produced a poster. You know, that would be what a scientist would expect to do for showing what their research is anyway. It would have been lovely to have had a designer or an artist as well, but I think that's going to have to be pushed forward to next year, because the time frame clearly hasn't been enough to get that part of it organised. So I shall continue discussions with Winchester School of Art, who were very interested in coming into the project, but there's the way they've got the courses organised hasn't really suited our time frame. So I think they need more time to think about it, so maybe next year.
But talking about time, I suppose the thing, obviously we're talking about with the project and how it will evolve, but I suppose the thing to do is, first of all, email addresses. I'll send around a list of everyone's email address after this meeting, so you'll have the contact of the raw scientist or writer. And I suppose it's a good thing in this meeting, if you're with your writer or scientist, to think about the next time you might meet, whether it's a visit to the lab, how that might work, set up when that will happen. And in terms of these dates, the next date will be a workshop in January. I'll send around a list when it's confirmed, where there'll be a chance to take your works in progress, see how they're going, get any feedback about things. Probably late January, January 21st, January 22nd. And then the final showcase in March. And as Francis was saying, what we'll be producing is a poster. Now, sometimes people use images, and images work well if the type of science that's involved has an image attached, perhaps with a poem on it. And then there's also the opportunity for the scientist to have some words and respond to the poem as well. So this is the nice thing, that it's quite 360 degrees. So there's not only a chance for the writer to produce some artwork in response to science, but there's also a chance for the scientist to respond in some way with what the writer has done, and that can happen on the poster as well.
And I actually sent round to the scientists an example, a couple of examples from last year. That there's also an online gallery which is nearing completion, and I will put the ones from last year onto there, and if I can get hold of them, the ones from the year before as well, and then yours will go on in turn, because that's a new thing, and that's definitely going ahead.
And were there any questions about the logistics of the project, or what happens next, or anything like that?
Is it okay to do like a short video for that? Because I actually did my undergraduate, which is the School of Arts, and for my final project, I actually really want to get to know scientists and make a video like this. So is it okay to make a video instead of poster?
Would it has to showcase the poem or piece of writing?
Yeah.
And then it has to be kind of showable at the event. That's and it would just need technology setting up on level 4 of the Hartley Library, which is where we'll have the exhibition launch party of your results. So you would have to perhaps supply the technology. I have seen on that level at an exhibition things with video installations, so it's clearly doable. But you might have to supply the laptop and so on, and then the rest of the exhibition would be left in place for a week. So there's that angle to cover as well. And I've seen installations where videos have been part of the exhibition and they've been left in place for a week. But I'm not sure whose video machines they were, whose laptops they were or anything. So we wouldn't be able to supply you with the technology to do that. But if you had it and were willing to let it sit there, that would be okay.
Great.
Any other questions about, I think, Rebecca?
Yeah, you've talked a lot about poetry, but it doesn't have to be a poem,
Well,
what's your party like?
Well, yeah, there isn't exactly a pattern because we don't say to people, and you have to write a poem. We just, something will come out of it, and most of the time it just seems to weirdly turn into poetry, even where people have said, well, I can't write poetry, I've never written a poem in my life, and then they somehow end up writing poetry. That's happened several times, hasn't it? And that's all I can say, really. I'm not going to prescribe anything to anybody, because as a writer, you'll find your way around it. You'll do something. You will complete the task, because it'll just happen like that. It might be that, as Dan was saying, and as we were just saying in a conversation just now, the reason why people seem to drift over into poetry, even taking themselves by surprise, is because science is constantly trying to describe or discover something that isn't there yet, which is posited in people's brains first as a possibility. And that's so conceptual and so something to do with the imagination that maybe that's why the writer tends to then start to do that, and it turns into poetry, even though maybe they thought it was going to be a perfectly straightforward piece of narrative of some sort. I don't know. And I'm really looking forward to what Evan Pacey does, because his natural medium for writing is drama. So, you know, this is the point though, it's discovery, isn't it? We're doing an experiment here. This is an experiment. And that's why I said at the start that whatever you've got when it comes to the point where we show it, that's your result. It wouldn't be appropriate really, because this is an experiment, if you kind of said, oh, I can't show that, it isn't finished yet. You know, it's a big experiment, and sometimes you don't finish an experiment just like that to a deadline. I know normally as a writer, if you had a commission, you'd have to finish the piece of writing by the deadline or they wouldn't pay you. But, you know, this is a little experiment in what it's like to write to a commission, but it's more than that, it's an actual experiment. So what you write to this commission might have achieved less than finished status.
Assuming the answer is possibly.
Yeah.
What do you think about that, Rebecca?
I don't know.
You have to just write something like you normally would and see what happens. Yeah.
The thing is, though, that if you're a writer of prose, as it were, it feels slightly arrogant walking into the poet's domain and assuming one can immediately start writing like that.
No, you see, because I don't agree there that there's a domain in the first place. I agree that some people have chosen to deliberately made a choice that they're going to write poetry, so they've acquired skills for themselves, and maybe somebody who writes non-poetry hasn't gone into that kind of skills area and learned how to do a sonnet and how to do a villanelle and so on. But, having said that, I enjoy reading so many different writers, and I can only say that their writing, even though it's prose, is extremely poetic. You know, I like it because of its poeticness, but it is prose. But at the same time, it shares something with poetry that's so uniquely to do with poetry. So there's that. I don't know what you call that.
Well, I think in previous years you sort of said that it's fine if it's poetry or prose, but that what you didn't want to encourage was narrative.
If somebody sets out to write a short story, we've had one experience where that didn't work because the writer set out to write a short story, but it ended up that they wrote about a scientist somehow, and it ended up being about the scientist. It was a strange thing, but this is an experiment, so you could expect a few strange things.
Setting out.
It ended up almost like a kind of, it ended up, it was a kind of, there was a friction between those two that didn't ever seem to have quite resolved itself.
Well, you did mention fights as obviously being a one thing with poetry and science.
Perfectly valid result.
Very amicable.
Perfectly valid result. It didn't look as if they'd enjoyed it very much. It was like a tussle. But, you know, it's a valid result. And this is experimental.
Are there any other questions or about the project?
My favourite book from last year is a book by Kathleen Jamie, who's a wonderful Scottish poet, who wrote a series of essays. And I think it's brilliant when poets write in prose. And one of her essays, it was a series of essays on natural history, and she treated cancer cells as an aspect of natural history. And that was a brilliant thing. If anyone's interested, it's called Sightlines, really wonderful book. Do you know? It's brilliant. But that would be for me a model of writing about science, a poet writing about science. In a prose form, unfortunately.
Well, anyway, would you mind email because I think they have university one on the...
Yes, sure, okay. I think we go on about vibrating by its temperature, essentially energy.